Okay, everybody, this is discussion 6.1. It's all about the mole. We're going to talk about what it is and why we use it. How can we determine what is called the molar mass of a compound, and what's the relationship between moles, the mass, and the number of particles. All right, so I want to give a couple notes first. Now, this unit is called stoichiometry because this is what we're going to be doing, and it really is awesome. You're going to see how cool it is. All right. Now, you're going to need a calculator every single day. Okay. Now, if you don't own a calculator, you can borrow one of mine, but if you do, please bring your own because I do not have enough for the entire class. You have to practice this. You've heard me say this before. It's absolutely true. You have to practice this, okay? If you practice a little bit every day, you're going to get this eventually, okay? And it's not going to be perfect the first time, but you're going to see we do the same thing over and over again, so you're going to get comfortable with it eventually if you practice. Okay, so what is a mole? Well, let's go ahead and define that word mole. In the simplest terms, a mole is just a word that represents a specific quantity, right? So a word now we have other words in the English language that represent quantities. When we talk about socks, we talk about there being a pair of socks. And we know that a pair means that there are two. We generally buy eggs in a dozen, right? So a dozen is a word that represents the number 12. Right? Now, when we're talking about a mole is the same thing as a pair or a dozen. It just represents a different number. And that number is 6.02 times 10 to the 23rd. Now that's a 6 with 23 zeros after it, or 602 with 21 zeros after it. It's a very, very big number. It actually looks something like this. Holy McGillicuddy, that is a big number, all right? So we use the word mole because chemists are concerned with things like atoms and ions, things that are incredibly tiny. And even the smallest sample of matter is made up of gajillions of atoms. Right? So we use the mole as a way to count atoms in a way where we don't constantly have to use numbers with all those zeros. Okay, so what is molar mass? Well, molar mass is the mass of 1 mole of a compound, or an element, or an ion. I'm just going to abbreviate compound here. All right, so if I look at the periodic table, we see masses on the periodic table. Now, I just want to note when we get masses from the periodic table, we'll always take them to 2 decimal places, no matter how many decimal places the table gives us. That way, we always come out with the right answer. So if we look at carbon on the periodic table, you'll see that it has a mass of 12.01. That means that 1 mole of carbon atoms will have a mass of 12.01 grams. Right? So we can relate the number of grams of a compound to the number of moles of compound. Now, since it's the mass per mole of a compound, the units will be grams per mole, or grams divided by moles. All right? Now, this becomes a really neat conversion factor to use in dimensional analysis. If we know that 1 mole of anything, and I'll just say, so we'll do 1 mole of star, will equal the molar mass of star. Right. So the example I gave you before was 1 mole of carbon will have a mass of 12.01 grams. Right. If I look at the periodic table and see, let's see, what's a good one? Arsenic, As. The mass on the periodic table is 74.92, so 1 mole of arsenic has a mass of 74.92 grams. Now, this gives us a handy conversion factor where we can convert moles of arsenic into the mass of arsenic. Or if we had the mass of arsenic, we could determine the number of moles. And we'll do some practice with this. All right, so first of all, I want to calculate the molar mass of calcium nitrate. Now, to do this, all we have to do is add up the masses of each atom in the compound. All right, so we have to consider how many calciums there are, how many nitrogens, and how many oxygens in the case of calcium nitrate. Now, we have to remember that NO3 is the nitrate ion. Each nitrate ion has 1 atom of nitrogen and 3 atoms of oxygen. This 2 outside there tell us that we have 2 nitrate ions in this compound. That means we'll distribute that 2 throughout, and it gives us 6 oxygens and 2 nitrogens. And of course we have 1 calcium, because calcium has a subscript of 1 in front of it that we just can't see it. So to get the molar mass, which we'll denote with a capital M, a fancy looking capital M, we're going to take the mass of oxygen and multiply it by 6, and add that to the mass of nitrogen and multiply it by 2, and add that to the mass of calcium. When we do that, we'll get the molar mass. So oxygen is 16.00 grams. That number comes from the periodic table, times 6, plus nitrogen, which is 14.01 grams per mole, times 2, plus the mass of calcium, which is 40.08. So when I put that into my calculator, 16 times 6 plus 14.01 times 2 plus 40.08, I get a molar mass of 164.10. I'm going to put the unit over here so we can see it, grams per mole. Now when you put that into your calculator, you're going to get 164.1. So I will add a 0 because we're going to always report our molar masses to 2 decimal places. So the next problem is just another way we can use molar mass. Now we know that the units of molar mass are grams divided by mole. Right? So if we're given the number of grams of a substance and the number of moles, we could just divide one by the other to find the molar mass. So in this problem, we're given 0.2 moles of a substance, and we find that the mass of the substance is 6.4 grams. What's the molar mass? Once you see those words, molar mass, that should tell you grams per mole. All right, so we're going to take the number of grams, which is 6.40 grams, and divide by the number of moles, which is 0.200. 6.4 divided by 0.2 equals 32.00 grams per mole. Now again, the calculator is going to give you 32, but we're going to plug in 32.00 so that we have 2 decimal places in each. All right, so we have 2 handy conversion factors that we can use to convert the number of moles to the mass of a substance or the number of particles that it's made up of. All right, so I know that 1 mole of any substance will have 6.02 times 10 to the 23rd particles in it. So what we have here is a conversion factor that we can use to convert the number of moles to the number of particles. So if we're talking about an element, if we know how many moles we have, we can determine how many atoms of it we have. Now I can also, if I know the number of moles, calculate the mass of a substance using the conversion factor we talked about before, where 1 mole will always be equal to the molar mass of the substance. Okay, so let's do a little practice with this. These 2 conversion factors plus 1 more. All right, so we're going to think of molar mass as a conversion factor. All right, so the molar mass of water we just determined is 18.02 grams per mole. So when you think grams per mole, think of it like of an equality. 18.02 grams of water is equal to 1 mole of water. Then we can use dimensional analysis. Right? So let's do a little example. It says, how many moles are there in 9.01 grams of water? Right? So I have to ask myself, do I have a conversion factor that connects the mass of water to the number of moles of water? And indeed I do. We're going to use the molar mass conversion. So we're only going to need our fence to have one vertical line in it. And of course, we'll put our smiley down here. We're starting with 9.01 grams of water. Now, when you're putting your units into the problem, be very specific. It's very important that you be very specific because you're going to need those units to figure out how to use the conversion factor. So I'm going to use my molar mass conversion factor, and I will put 18.02 grams of water down below for every 1 mole of water up above. And I see that 9.01 times 1 divided by 18.02 is 0. Water. Okay. Let's do another example. It says, how many moles of water are in a bottle of water that contains 500 grams? Right? So write out the conversion factor. 1 mole of water is equal to 18.02 grams. Right? So we're going to start with 500 grams of water. Now, because we have our conversion factor, we only need to have one vertical line in our fence. We'll put our little smiley down there. Right? We're going to use the same conversion factor. Since it's still water, we're going to have 18.02 grams for every 1 mole. So when I do this problem, I'm going to say 500 times 1 divided by 18.02 and equals 27.74 moles. All right, now let's try an example with molecules. Now we're talking about carbon dioxide. Right, so we're talking about a compound which is made of molecules. So, do I have a conversion factor that tell me how many particles of CO2 will be in 1 mole? I absolutely do. 1 mole of anything is 6.02 times 10 to the 23rd. So in this case, it'll be that many molecules. So, since I'm going from molecules into moles into molecules, and I have a conversion factor that connects those two things, I only need one vertical line in my fence. I'm starting with 6.23 moles. Now, the unit for mole, as you can see, is just dropping the E off from mole. I guess that's just to save a little bit of space and time. All right, now, I'm going to use the conversion factor I have here, only now I'll put 1 mole of CO2 in the denominator so that moles of CO2 cancel, and I'll put 6.02 times 10 to the 23rd molecules of CO2 up above. And I put that on my calculator. It goes 6.02 times, or 6.23, times 6.02 E23, and we get 3.75 times 10 to the 24th, and the unit is molecules. Now, I will show you how to use that E button in class if you're just watching this video to get caught up. All right, so now we're going to do one more example. It says, how many aluminum atoms will be in a piece of foil that weighs 2.55 grams? So to set this problem up, I have to ask myself, how many steps will I have in my fence? Well, I have one conversion that is 1 mole equals the molar mass, and my other is that 1 mole of anything will equal 6.02 times 10 to the 23rd. In this case, it would be atoms because we're talking about aluminum. So I do not have a conversion factor that directly connects the number of grams to the number of atoms. I have one that connects moles with mass and one with moles with atoms. So if I have a mass, I can use that mass to calculate the number of moles. Think about it kind of like a wheel with spokes. Right? And if I know the number of moles, I can also calculate the number of particles in the sample. Right? So I can't directly go from mass to particles. The first thing I have to do is convert to moles, and then I convert moles into particles. So that means I'm going to need a fence with 2 steps in it. Put our smiley. Bam. Okay. So we're starting with 2.55 grams of aluminum. Now, because I have my periodic table, I can use the molar mass conversion factor and say that each mole of aluminum has 26.98 grams. So I'll put 1 mole of aluminum in the numerator. Now, again, we're doing the same thing we were doing with apples and oranges, only now we're using grams and moles. Now I can convert to atoms by using my other conversion factor that says 1 mole of aluminum is equal to Avogadro's number, or 6.02 times 10 to the 23rd atoms of aluminum. And when I put this into my calculator, I'll say 2.55 times 1 divided by 26.98 times 6.02 times 10 to the 23rd. And I get that there, in that sample of aluminum, there's 5.69 times 10 to the 22nd atoms.